Welcome, this is section 12.2 with indefinite integrals. That is, we're going to be doing more integrals, but we're going to be working them in terms of functions and their derivatives. So please, I highly recommend having these formulas right next to you when you're working out the problem, because the more you see how they are correlated, the easier it gets for you to work these problems out. So these are the formulas. I will give you time to go ahead and take a look at those formulas. Pause the video, take a look at the formulas, and now let's go ahead and work the problems out. Again, here I'm going to show you the formula way, and again, a simple way to look at it. Okay, so the first problem is integral x power 7 e to the power x to the power 8. Now, the formula that I use is e to the power f of x times derivative of f of x d of x. Now, this could be very confusing, but let's go ahead and take a look. So let me write down my integral x power 7 e x to the power 8 d of x. Now, I am going to take x to the power 8 as my function. So my function f of x is x to the power 8. And now, the derivative of this function is 8 times x to the power 7. Now I'm going to look closely to see, yes, I do have the function and I do have the derivative. But if I look, the 8 is missing here. Do you see that? The 8 is missing. So what I'm going to do here is I'm going to find the integral and I'm going to multiply and divide by 8. So as you see, when I multiply and divide by 8, I am not changing the integral. And now what I'm going to do, because I don't need the bottom part, I'm going to take it and put it outside as a fraction. You don't see the numerator is automatically 1. And now let's go ahead and see. I do have the function and I do have the entire derivative. And that compares to this. You have your e to the power of f of x times the derivative. And what's the formula? E to the power f of x plus c, which is, this 1 by 8 stays. E to the power f of x is nothing but x to the power 8 plus c. Do not forget your c. Now, I don't memorize the formulas, but this is how I look at it. So I'm going to move all of this up, and I'm going to use a different color to show you my method. This is x to the power 7 e to the power x to the power 8 d of x. In my mind, I see, okay, this is e power x. So the derivative of e power x is e power x. The integral of e power x dx is e power x. So for me, the derivative of the integral is the same thing. But what I look at is this x power 8. Do I have the derivative of x power 8? The derivative of x power 8 is 8 times x power 7. But if I look closely, I only have this. I don't have the 8. So what I do is I multiply with 8 and then I divide with 8 outside. And now, because I have the derivative and the function, I know that the integral of e power x power 8 is e power x power 8 plus c. So if you look closely, it's the same way, but the more you do, you will automatically see the derivative, you'll see what's missing, and you will see what the final integral is. All right, now let's go ahead and take a look at the next one. So here I have, let me write this down. I have integral, a different color. I have integral 1 over 4 plus 5x squared 10x dx. Okay, now let's see how do we work this out. Again, first step is I will see a function. Yes, I have a function, so I'm going to go ahead and write that down. I have my f of x is equal to, let me move all of this to this side so I have space. F of x is equal to 4 plus 5x squared. Now what is the derivative? The derivative is 10x. So I do have my function and I do have my derivative. So the only thing I'm looking at is, what is the integral of 1 over x? The integral of 1 over x is ln absolute value of x plus c. Okay, that's all I have to think. You can go ahead and use the formula here, which is right here. I have the function 1 over f of x times the derivative of x. The integral is f of x plus c. So here you only look at what is the function. So for me, this is my concern. So 1 over the function, the integral of 1 over the function is ln x plus c. So this is ln, this is the entire x, right? So absolute value of 4 plus 5x squared plus c. And that's exactly what your formula tells you. You have your function, you have the derivative, and the integral is ln fx, ln absolute value of the function plus c. So, but here the key is you have to know these integrals, just like how you, oh, I forgot the dx. Just like how you memorize your derivatives, you have to know your integrals as well. Now let's go ahead and see if I have, yes, I do have another function here. Now let's take a look at the function. Here again, you have the formula next to it. The formula is going to be f of x power n. Now you might ask me, how do I know what formula I'm using? Well, that's a very good question. You will look at what the function is. When I have the power function, I'll use the power formula. When I have, where is it? When I have e power x, I'll use the e power x formula. When I have 1 over, remember this is not a power. This is just 1 over x. This is to the power 1. I'll use the function 1 over f of x. And this is different here because this is not 1 over x. This has a power 2. So this automatically becomes a power function. So you'll write this formula down and let's take a look. Again, when you're looking at it, you know this is your function, right? This is your function. Let's see. This is your function. And the first thing you should ask yourself is, okay, I have my function f of x is equal to 4 minus x power 9. Let me see if I have the derivative, because if I do, I'll simply act like it's not there. Minus 9 x power 8. Now the question is, do I have this? You do, but you only have partial. You don't have this negative 9 part. That's fine. I'll go ahead and stick that in there. So this is integral x to the power 8 divided by 4 minus, I forgot, x to the power 9 whole squared dx. Right? That's what your integral is. Now you found out what your f of x is. You did find out what your derivative is. Now your goal is to go ahead and make sure you have that derivative in there. Remember when we found out this negative 9 is missing? Not a problem. I plug negative 9 on the top. Then I divide by negative 9 in the bottom. That way I'm not changing the function. And now, look what I'm going to do. I'm going to rewrite this. You know I don't like to work with the quotients. So it's negative 9 x power 8 times 4 minus 9, 4 minus x to the power 9 whole squared dx. I have the function, I have the derivative. Now I simply have to find the integral. So it's like you're finding the integral, oh, this is negative 2, sorry. You're finding the integral of x to the power negative 2. Let me write this in a different color. It's like you're finding the integral of x to the power negative 2, which is x to the power negative 2 plus 1 over negative 2 plus 1 plus c. So this is nothing but x to the power negative 1 over negative 1 plus c. Again, miss, I cannot think of all that. No worries, simply use your formula. So you do have your function to the power n. You do have the derivative. So it's simply function n plus 1 divided by n plus 1 plus c. And that's exactly what you will be doing. The integral is the -1/9 stays. Function 4 minus x power 9 to the power -2 plus 1 over -2 plus 1 plus a c. And that is -2 plus 1 is -1. This negative becomes a positive. 1/9. 4 minus x to the power 9. -2 plus 1 is -1 plus c. And that is going to be your final answer. So knowing what you're looking in the formula is very important. Now let's go ahead and try this one. Okay, for this one, it is the same formula, but it's slightly different. Let me show you how first. Again, you see this is x plus 8. Very good. I'm going to say, hey, wow, I have x plus 8. Very good. And what's my derivative? Derivative of x is 1. That's it. Oh, but wait a minute. I have this extra x here. What am I going to do with it? That's when you know you will be using substitution. When you have extra terms, you will substitute them, or you will rearrange the terms that you don't have that extra term. And let me show you how. What I'm going to do here is I'm going to erase all of this, and I'm going to go ahead write this function, which is, let me write this in the bottom here. This is integral x over radical x plus 8 dx. Okay, now step 1. I'm going to take my, let's say, x plus 8 is u. You can take u, v, but in this textbook they use u, so you take u. So my x is equal to u minus 8. And if I find the derivative of dx, derivative of x with respect to x is 1, derivative of 8 is 0, so I have dx is equal to my du. Okay, or let me rewrite this one. Let me show you how I got this. So derivative of x is 1, derivative of 8 is 0. I'm finding the derivative with respect to x, so du over dx. So 1 is equal to du over dx, so my dx is du. Okay, now once I know that, again, why are you using substitution? Because the derivative of x plus 8 is 1, and I have this extra term here. So that's when you know you have to substitute. I'm going to erase, oh, never mind. So now let's go ahead and find the integral. Integral, remember what my x is? My x is u minus 8 over, remember what my x plus 8 is? My x plus 8 is u. So this is radical u. Remember what my dx is? My dx is du. Now again, I want you to pay close attention here to see how I'm going to simplify this problem. This is u over radical u minus 8 over radical u, the whole thing du. I can still simplify this. U over radical u is radical u minus 8 times u. When I bring the radical up, it becomes negative half, and the whole thing du. I can still, I don't have to, but I'm just showing you step by step. So this is u to the power half du minus 8 integral u to the power negative half du. Now you don't even need a formula. You know this is u to the power half plus 1 over half plus 1 minus 8 times u to the power negative half plus 1 over negative half plus 1. Do not forget your big C, because this is integral. And now this is nothing but u to the power half plus 1 is 3 over 2 over 3 over 2 minus 8 u to the power half over half. So 8 divided by half, this is going to be 2 over 3 u to the power 3 over 2 minus 8 divided by half is 16 u to the power half. Do I have space for the c? This half looks weird. Half plus c. And now I can't leave it in terms of u. I have to change it back to my x's because that's what I changed them, right? So this is simply 2 over 3 over, remember what my u is? X plus 8 to the power 3 over 2 minus 16. My u is x plus 8 to the power half. Why is that half so weird? Half, to the power half plus c. And now let's see if that matches. There you go. So very carefully, what you're doing here is first you're going to take your x plus 8, change it to u, you're going to find the x, and then you know your du is your dx, and then you go back here and substitute your u, substitute your x plus 8, and because that's a radical, you're going to divide everything with the radical, change your radical to the power half, and because it's in the denominator, it becomes a negative half, and then you're going to use the formula of integrals, which is integral of x power n dx is x power n plus 1 over n plus 1 plus c, right? You're going to use that formula, and you will go ahead and find each of these, simplify, and then change your u's back to your x's. And again, all this is done because I don't have the exact derivative and because of this little extra x here. If that wasn't there, life would have been simple, right? All right, again, if you have questions, you're going to go back, rewatch it, stuck with the problem, take a screenshot and send it to me. Now, let's go ahead. For this one, I need space. So let's see. To answer this one, what was that? That was integral 3x squared x cubed minus 5 dx. Here, they're asking us to work this integral with and without substitution. So I'm going to divide this into two parts here. And I'm going to do two different integrals so you can see what is going on. First, I'm going to do without substitution. Miss, what is that? Simply multiply. So this is integral. 3 times x squared x cubed is 3x5 minus 3x squared 5 dx. So this is going to be, I don't think I have to put integral. This is 3. Integral of x power 5 is 5 plus 1 over 5 plus 1 minus 3 times 5 is 15. Integral of x squared is 2 plus 1 over 2 plus 1 plus c. I'll simplify this. This is 3x power 6 over 6 minus 15x cubed over 3 plus c. Simplify this further. This is x power 6 divided by 2 minus 5x cubed plus c. So I simply multiplied. I didn't think about substitution or anything. Boom, boom, boom. I did it. Now let's see how the other side is going to look. For here, again, remember, you first look at the function. look at x cubed minus 5. So I'm going to take my function f of x as x cubed minus 5. And you'll find the derivative. What's the derivative of this? 3x squared. Wait a minute. I have the derivative in here. So when I have the derivative, how do I take this? This is to the power 1. Remember, what is integral x dx? Integral x is x1 plus 1 over 1 plus 1 plus c. And that's exactly what formula you're going to use. To the power f of x plus 1 over n plus, f of x to the power n plus 1 over n plus 1 plus c. So key here is to find the function, to find the derivative. And if you have that, you will just treat this whole thing as a simple term, x power x. So this, you have the derivative, you have the function, and the derivative. So in your mind, you're saying, hey, all of this is nothing but integral u, which is u to the power 1 plus 1 over 1 plus 1. Again, having the formulas next to you is always helpful. So let's go ahead and work this out. This is going to be x cubed minus 5, 1 plus 1 over 1 plus 1 plus c. This is nothing but x cubed minus 5 squared over 2 plus c, which is nothing but, I'm expanding x cubed, which is x power 6, minus 10x cubed plus 25 over 2 over 2 over 2 plus c. So go ahead and multiply x cubed minus 5 times x cubed minus 5, and that's what you will get. This is after I multiplied. You can do FOIL, you can do multiplication. And now, can I simplify this? Yes, I can. This is x to the power 6 minus 5x cubed plus 25 over 2 plus c. Now let's go ahead and compare if these two are the same. I'm going to go ahead and zoom this here. As you can see, this is x power 6. I have x power 6, negative 5x cubed, negative 5x cubed. But wait a minute, I have this 25 over 2 extra here. And that's exactly, you will have the difference. The difference between substitution without substitution, it differs by a constant 25 over 2. Okay, so always when you see multiple terms, you will always think in terms of the function and its derivative. All right, let's see if we have more. Is this the last one? Yeah. All right, let's go ahead and take a look. Let me write down the integral here. This is integral x radical, what was it? 8 minus x squared dx. Again, if I have a function, if I have the derivative, my life is easy. Let's go ahead and see. My function f of x, I want you to pause here and see if you can find your f of x. My function f of x is 8 minus x squared. And my derivative is negative 2x. But wait a minute. I have a part of my derivative here. That's okay. Remember, you can always plug in. You can multiply and divide. So what I'm going to do here is I'm going to multiply with negative 2x radical 8 minus x squared dx. Because I multiplied, I have to divide. And now I have the derivative. I have the function. This is a power function. I can rewrite this as 8 minus x squared to the power half dx. Power function, that's your formula. F of fx to the power n plus 1 over n plus 1 plus c. So this is going to be negative half 8 minus x squared. This is half plus 1 over half plus 1 plus c. And negative half. This is 8 minus x squared. Half plus 1 is 3 over 2 over, this is again 3 over 2 plus c. Simplify this, half divided by 3 over 2. This is going to be, this is negative 3. Is that what I get? Yeah. Negative 1 over 3. Negative 1 over 3. 8 minus, okay, let me show you this one. Half 3 over 2. So this is negative half and 8 minus x squared 3 over 2. 3 over 2. You know what? Let me just do this one here so you don't have any confusion. I'm going to erase this step. So I'm going to rewrite this as negative half. And this is going to be 8 minus x squared to the power 3 over 2. I'm going to flip this function times 2 over 3 plus c. So positive 2, negative 2 get cancelled. And I have negative 1 over 3, 8 minus x squared to the power 3 over 2 plus c. Your final answer. Ow, what kind of shape is that? Your final answer. Okay? All right. So this fraction, just be careful with these fractions and you should be fine. All right, let's see. What's the next one? I like 1 over the functions. You see, this is 1 over, this is like over the function. And again, here pause and see if you can find your function. Here, my function is going to be 1 plus 4 e power 3x. Now you're going to ask me, Miss, what's the derivative? This is my function f of x. When you're dealing with e power x's, they are the best. The derivative is going to be 4 e power, not 4 actually, yeah, 4 e power 3x times derivative of 3x is 3. So this is going to be 12 e power 3x. So let me redo this one. Let me rewrite this whole thing here so it's easy for you to understand. E power 3x over 1 plus 4 e power 3x dx. Again, I'll start with this as my function. So my function f of x is 1 plus 4 e power 3x. The derivative of this function is going to be 4. Derivative of e power 3x is e power 3x times derivative of 3x is 3. So this is 12 e power 3x, as you can see. Now, do I have the derivative? Yeah, just the partial. That's okay because you by now know you can multiply and divide by that constant, 4 e power 3x dx. And now you will use your formula, which is 1 over the function times the derivative is simply the log of that function. So this is simply 1 over 12 ln 1 plus 4 e to the power 3x plus c. Now, remember, derivatives and integrals are inverses of one another. Now you might say, Miss, how are all these formulas working? Let's quickly go ahead and find the derivative of this to see if it even matches. Okay, let's go. I'm doing the derivative in a different color. You're not asked to do in your problem. This is just me showing you that they are the same. So derivative is 1 over 12. Derivative of ln is 1 over x. So derivative of ln 1 over 4x is 1 over 1 power 4 e to the power 3x times derivative of 4 e to the power 3x is 4 times e to the power 3x times 3. And that is nothing but 12 e to the power 3x over 1 plus 4 e to the power 3x. Now look closely, 12 and 12 cancel each other. What are you left with? You're left with e to the power 3x over 1 plus 4 e to the power 3x. So you go back to the function. That means your answer is right. Remember, this purple part you didn't have to do, but I just did it so you can see that when you find your integral and when you find the derivative, they're inverses of each other. So you get back the function itself. Hope this helps.